Let's show them some encouragement. Welcome the CO2 Crew, Hoonie, Hope, Sophie and Teo.
It's terrible for the environment too.
Scientists said that cars release gases that make the earth hotter.
What if we can make a car that doesn't need petrol?
What about soda and ketchup?
No. Let's try using a reaction. Maybe baking soda and vinegar.
Oh yeah, maybe it can move. Ooh, that's busy. Do you think you can really move a car? No batteries, no petrol?
Let's design a clean, face-powered car.
Yeah!
Oh, hi there.
I'm Teo.
I'm Hoonie.
I'm Hope. And I'm Sophie.
And we are the
CO2 Crew.
Wait, are you saying we can race a car with the bubbles like fizz power?
Let's find out. Our question is, how can we innovate a car by using a chemical reaction
that makes gas from solids and liquids to race a car, and how could the amounts affect how far the car goes?
Let's race with science!
Did you know 2 kitchen ingredients can cause a mini explosion?
Introducing the dream team,
Vinegar and baking soda.
One's a sour liquid, the other's a powdery solid.
but when they meet, boom!
It changes states of matter from solid liquid to a gas. The gas, carbon dioxide, pushes out, propelling our car forward.
It's like our car has a fire-powered rocket engine.
Sounds like scientists gave us a turbo boost.
Now let's build a CO2-powered supercar.
We need some materials such as
Some baking soda and vinegar.
Measuring tape,
a measuring spoon and a plastic bottle, straw, thin Lego poles, and some bottle caps.
So,
How are we going to build our car? We can make our car out of a plastic bottle for it to be convenient.
then we'll attach the bottle to the wheels and add the magic syrup, vinegar.
And scoop a certain amount of tablespoons of baking soda and drop it in.
Finally, shake the bowl and put the car on a flat surface and watch the car start moving forward.
Moving on, let's check if this is a fair test.
By using cows move softly.
We must change how much vinegar we add.
We will measure the amount of distance the car traveled.
And lastly, we are keeping everything else the same.
We can't forget safety.
We need to be aware of the liquid in the bottle because it might get in our eyes.
We can manage this by keeping a safe distance from the experiment. What if the liquid gets spilled on the floor?
Oh, you're right. One of us might slip and get injured.
We must be aware of the liquid and carefully clean up the mess. What do you think will happen?
If the amount of vinegar,
Is increased.
then the car will travel further.
Because the more vinegar we add, the chemical reaction will produce more carbon dioxide.
Creating more thrust.
Can you guess which one is going to be the winner?
20 mil is small but mighty. Focus is everything. Balance is key. 30 mil is the perfect middle ground.
The more the better. 40 mil, definitely winning.
Alright, let's see who's really the best.
Unfortunately, the videos couldn't play, but let's reflect on what happened. As you can see, the 40 mil car traveled the furthest.
This is because the more substances used,
the bigger the chemical reaction was, causing the momentum to be stronger.
From looking at our graph, we can easily see that the 40 mil outputs both 20 mil and 30 mil.
From our observations, we learned that this chemical reaction can change matter and create motion.
When vinegar and baking soda reacted, bubbles and gas formed quickly. The gas built up pressure and pushed our car forward.
more vinegar made more gas, which gave the car more momentum, which led to more movement.
This means innovation improves the ecosystem.
Our hypothesis matched our results. During this experiment, we did notice some flaws. We noticed that the car didn't go straight and it was hard to measure. To fix this, we could draw a long line or create a track on the floor with tape.
So the car can go straight, or we can just start from a narrow groove.
In addition, it was hard to get the timing to let go of the car, so we couldn't see its 100% of moving.
To fix this, we could drill a small hole in the cap and make a device to make it open quickly. Or we could just use a transparent bottle to visually check the gas level and launch it based on that cue. Our experiment was a success.
Next time, couldn't we make the car go further?
What if instead of changing the amount of vinegar, we can change the amount of baking soda?
Oh, and we can also change the size of our bottle. And if the bottle is bigger, would it go further?
Maybe even 3D print the car to make it more appealing for customers.
Let's also change the size of the wheels. Would the weight slow it down?
We sound just like real scientists.
Wow, our car zoomed off like a rocket. Thanks to the gas from the baking soda and vinegar reaction, who knew gas could be that powerful?
There are so many real-life scenarios, just like our experiment.
Like airbags in cars. When there's a crash, a solid burns up into a gas, making the airbag inflate.
That's just like our experiment. Yep, even in baking, gas makes the dough rise.
Experiment's over, but our science goes on.
You're like a fizz up when you start to mix up. You're my vinegar, baking soda pop.
Thank you for listening.
If you're curious,
Please make sure you ask us for the questions.